Hello dear friends, I welcome you all for the lecture number 10 on a Hammett linear free energy relationship. In this lecture we will discuss about the concave downward deviation. In last three lecture we have discussed a concave upward deviation. Concave upward deviation is seen when there is a change in reaction, uh, change in mechanism of reaction. When the mechanism of reaction is changing, then in that case we have a concave upward deviation. Now here we will discuss a concave downward deviation. Concave downward deviation. Now this concave downward deviation is seen when there is a change in rate determining step. Mechanism of reaction is same, but only the rate determining step is changing. The best example of this is a cyclodehydration of phenyl triaryl methanol. Phenyl 2-phenyl triaryl methanol. Sorry. This is the reaction which is carried out in 80% aqueous acetic acid. Sorry. So this is cyclodehydration. Now let's consider the stepwise mechanism of this reaction, and then we will understand this graph. Here we have a concave upward deviation. Two row value we have. Row value is plus 2.67, and we have a row value minus 2.51 for electron withdrawing group. So let's have a stepwise mechanism. This is a four-step mechanism. First step is protonation. Second step is loss of this water molecule. Second step is loss of water molecule and formation of carbocation take place. In third step, the attack of pH ring take place. Simple Friedel-Crafts alkylation type, intramolecular Friedel type alkylation reaction. And last step is minus H plus deprotonation for the aromatization of a system. So this is four-step mechanism. This is third step. This is fourth step. Now among four, the steps first and four are faster, as it just involves the protonation and deprotonation, that is loss of proton or gain loss of proton or addition of proton is taking place, and therefore steps number 1 and 4 are faster. Now step second step second is a formation of carbo carbocation formation, and step 3 is a intramolecular intramolecular attack of pH ring on carbocation on carbocation. Now very basic or fundamental organic chemistry or concept of fundamental organic chemistry is uh, can be explained. We can explain this on the very simple fundamental basic of organic chemistry or organic reaction mechanism. So second step is a formation of carbocation. Second step is a formation of carbocation. So this formation of carbocation will be very faster, will be very faster when strong electron donating group is present. When strong electron donating group is present, then formation of this carbocation will be very faster, and therefore when electron donating group is there, then rate of this reaction will be, as the rate of this reaction will be very faster, this is not considered as a rate determining step, as the rate of this reaction it cannot be determined, and therefore the second step is also a faster step when strong electron donating group is there. Now the in third stage, the pH group attacks the pH group attacks on carbocation. Now when the substituent on this AR group, electron donating or electron withdrawing substituent, sorry, when the strong electron donating substituent is present on this aryl system, then this attack of pH ring on this carbocation will be very slow down, and this strong electron donating group will extra stabilizes that carbocation, and due to the stabilization of this carbocation, extra stabilization of this carbocation, the electron deficiency of this carbocation is now almost zero, and therefore attack of pH ring become very slow, and therefore when strong electron donating group is present, then third stage will be the rate determining. And now you can see that in the rate determining step, the electron density, electron here the reaction center is this carbocation, and during rate determining step, electron density is coming towards the electron reaction center. In rate determining step, the electron density is coming towards the reaction center, and therefore for this rate determining step, we have a positive row value. We have a positive row value which is shown over here. This is, we have plus 2.67 row value. And so here the conclusion is that when rate determining, sorry, when strong electron donating group is present, the rate determining step will be the third stage. Now what about the strong electron withdrawing group? I am writing over here by blue plane. When strong electron withdrawing group is there, then in this case the formation of carbocation is very slow, as electron withdrawing group destabilizes the carbocation, and therefore the carbocation formation will take the very much time, and therefore when electron withdrawing group is present, this carbocation formation will be the rate determining step. And once the carbocation is formed, that carbocation, that unstable carbocation will be radially attacked by adjacent pH ring, as that carbocation is very unstable, and therefore attack become very faster. And therefore, when strong electron withdrawing group is there, the rate determining step, when strong electron donating group is there, strong electron withdrawing, strong electron withdrawing group is there, the rate determining step is second, that is formation of carbocation. Why this step will be, why the formation of carbocation is very slow when electron withdrawing group is there? Because electron withdrawing group destabilizes the carbocation, and therefore that carbocation formation reaction will take a very much time, and therefore that will be the rate determining step. And once the carbocation is formed, when electron withdrawing group is there and formation of carbocation is take place, then pH group is readily attack on that carbocation, as that carbocation is very unstable and very much electron deficient, and therefore that pH ring is attacked with faster rate. And therefore we have a negative rho value as the carbocation formation. In carbocation formation, electrons are going away from the this carbon electron reaction center, and therefore for this reaction we have a concave downward deviation. For this reaction, we have a concave downward deviation, which indicates that whenever there is a concave upward deviation, the rate determining step of the reaction is changing. So this is all about the concave downward deviation. We have a 2 rho value. This is for electron donating group, where the formation of carbocation is faster, but attack of pH ring on carbocation is slower. And we have a negative rho value, that is minus 2.51 for the electron withdrawing group, which indicates that the formation of carbocation is rate determining step. Now, why the rate of this methyl, when X and Z is methyl, the rate of this reaction is faster. Now, because this methyl carbocation stabilizes the carbocation, this stabilizes the carbocation. But when X and Z is methoxy group, then this O methoxy group will stabilizes the carbocation, will stabilizes the carbocation, will extra stabilizes the carbocation. This methyl group only stabilizes the carbocation, but methoxy group extra stabilizes the carbocation by donation of electron by plus or effect, and therefore the rate of this methoxy group is decreased. As the carbocation get extra stabilized, the attack of pH ring becomes slower. The attack of pH, that is rate determining step, the speed of rate determining step become very slow compared to methyl group, and therefore when X and Z is methoxy group, the rate of reaction is very slow compared to when X and Z is methyl group. Now again, when X and Z is equal to chlorine, then this chlorine also, two chlorine group destabilizes the carbocation, and therefore as these two chlorine group will destabilizes the carbocation, and therefore the formation of carbocation become very slow. And as the formation of carbocation is rate determining step, the overall rate of this reaction is decreases. The summation sigma plus and summation and sigma minus indicate that, as here two methoxy group is present on two sides, that is on this aryl group as well as on this aryl group. Therefore here we have a two substituent constant which is denoted by summation, which is denoted by summation. This is about I discuss about this graph. Okay, thank you.